Okay, this statement here, changing the way we measure things, that was on the title of one of the ISAHP templates. And I like that because it kind of described what I am going to be trying to do here. And maybe a partial theme of what's going on. Title is Representations, Ratios, and Units. There's myself, there's Orrin Cooper and Idil from Turkey. We have been working on some work relating to inconsistencies. And one of them is the rank reversal issue. And so we thought we'd put something together for this conference. And one way to start off is just ask a couple of quick questions. Which investment is better? Would you prefer 3 or 5%? And most people would say 5%, but if I tell you it's 5% and $100 or 3% and $100, you'd probably want to take the 3% one because you'll get more money. So the points here is you have to kind of define what question you're trying to answer, what problem you're working on, and what's a representation of it. And in particular, when you're talking about a percentage or even priorities, you have to say a percentage of what? Okay. Now, let me go on to the next one. Here's another one. Is this true or false? If I looked at that, I'd say, yeah, that's true. The ratios are the same. But are the units the same? And if you look at this, the true or false ones, you'll see that the units are different. One's 100 kilos and the other's 10 kilos. Well, it's the unit that's in the denominator that we are interested in. Now, if I go to AHP and talk about pair comparisons, just consider a comparison in which one object A is 4 times better than B. If you had that, you would have a pairwise comparison where you could say A is measured as 4 of B, where B is the unit. So BP, the B property, it has a value of 1. It's the object that's used for the unit of measurement. It's in the denominator. It's always in the denominator. But that object that you use to make a comparison can be changed. For example, if the object A is the reference unit for the pairwise comparisons, the measurement would be BP is 1/4 of A. Now, here's one I want to just talk about very quickly. The concept of adding fractions. Oh, sorry, I think I'm on the wrong way. Of adding fractions. We all learn in basic mathematics that if you're going to add fractions, you can't add 1/4 and 1/5 directly. You have to make a common denominator. And the common like such as 5/20ths and 4/20ths, you can add those together to get 9/10ths, which makes sense. The common denominator is the of what unit that has to be combined. So that's always behind there, what we're doing. Now, priority vectors from pairwise comparisons are a little different. If I took those two objects, A and B, where A is 4 times B, you could get a vector here of 0.8 and 0.2. The priority sum to unity, that's what we do in AHP, and AP is still 4 times larger than B. Now, that normalization is a new unit or a different unit, as indicated by the measurement values for A and B. And since the priorities of this vector are less than 1, it implies that the unit of that vector is something greater than 1. Maybe you look at this, the one down the bottom. If B is the unit, then A is 4. If A is the unit, A is 1 and B is 1/4. But if you made those into a priority vector that sums to unity, what is the unit? And I would claim that the unit is really a composite unit. It's not a single object like A or B, but it's a composite of A and B. Sorry, here I'm jumping around just a little bit here. Now, what if we added an element to A and B? Okay, we added an object C, which is 1/2 A and twice of B in intensity. Then we could leave B as a unit, and we could put C in there, or we could have A as a unit, we could still have C in there, or we could have this composite as a unit, the original composite of A and B, and we could put C in there, but the sum would no longer add up to 1. If we wanted to make the priority sum up to 1, we would renormalize them in this manner to come to 1, and we would get different priorities. You notice that they change when you add another unit to it. In effect, up here, we have A and B as the composite unit, and down here we have 3 items as a composite unit. We get a 1 up here and a 1 down here, but a 1 here at the top does not equal a 1 down here, even though they're both 1s. And that's the issue I'm trying to emphasize. A fellow named Sajjad Zahir came up with this statement. I think it's a very useful one. Now, we wanted to analyze this from the point of view of rank reversals. And go back and look at rank reversals using this concept of units. What happens to the unit of measurement? And I want to go back and look at Belton and Gear because many people understand that and have looked at it before. But not many people have looked at rank reversals from the point of view of units of measurements and what happens to them. And so we want to go back and look at them. And I'm going to be using fractions rather than decimals for priorities. And the reason for that is fractions have the unit in the denominator. You can see what's happening. We're going to look at both the maximum mode first of Belton and Gear. I call Belton and Gear's method the maximum mode, and also the distributive mode of AHP. Now, Louise mentioned yesterday something about Belton and Gear's data. Belton and Gear, here's the data here that they use for their example. They started with 3 alternatives and 3 criteria. Now, they use what they called scores. Louise called them numerical values yesterday. We have taken the liberty to put monetary symbols after each of these criteria, only to signify that they are different criteria. However, if you take those number signs away, they're exactly the same as what Belton and Gear used for their data of their problem. And here's what they did with their maximum mode, the way they did it. Here's the original data over here, and here is their way of expressing priorities. But their priorities don't sum to 1. What they did is they picked on the maximum ones. Now, you've got to understand where Belton and Gear were coming from. They considered the criteria weights and the units of measure of the alternatives to be intertwined. They looked upon the criteria weights, and they're equal to 1/3, 1/3, 1/3 here. They looked upon those as being scaling factors for the units that are down below. In fact, this is a quote from them saying each criterion should be compared by direct reference to the options defining those units. In other words, when they're getting the criteria weights that are equal up here, you should be getting the criteria weights that are appropriate for the units of measurement you're using down below. That's a concept that comes from multi-aspect utility theory. It's common there. And so that's what they did. Now you'll notice they picked, I call it the maximum approach, their mode, because they picked the maximum alternative in each column, criterion column. B is the maximum of criterion 1, A is for 2, and criterion 3 has B again. Notice that each of those had a value of 9, 9, 9, 9. And because they had values of 9, 9, 9, Belton and Gear said, when we compare these things, they're all going to be 1/3, 1/3, 1/3. So those are what they use. And then they introduced alternative D, which was a clone of B. Except you notice B and D are exactly the same. Now, here's the results that they got. They got maximum mode with 3 criteria when they did it with just these 3, these weights. Now, you notice when you multiply the 1/3 times the units, which are in ninths, you get everything in terms of 27ths. And then you add them up, and here's the results they got. A was better than any of them. And then when they added D in there, D did not change their units. They didn't get a bigger or better maxima. The units stayed the same. Now the priorities with 4 alternatives, still in the unit of 27, still gives exactly the same numbers. There's no change at all in the values of the alternatives. So adding D does not change the maximum alternative, and being a copy of B, D gets exactly the same values. Now the next stage was what happens when you go to the distributive mode. Now the distributive mode operates quite differently. Criteria weights are not considered to be scaling factors. They're interpreted as values which distributed some overall quantum unit to items down below. And also in the distributive mode, alternatives are not expressed relative to the maximum value, but rather are summed to unity that we talked about before. You'll notice here that these priorities here sum to 1. These are priorities in fractional units. They sum to 1 in all the times. Now, an interesting thing about these criteria weights, Belton and Gear made them all equal to 1/3. There is some controversy as to whether that should have happened, because you can say here that the composite unit of the criteria in one column is 11 scores, and 11 scores for criterion 2, but 18 scores for criteria 3. If these are the units, you would not expect the criteria to be equal in weight. And so that's one thing I think that Belton and Gear could have done if they had followed their own advice. But they set these as equal, I think, because they followed the AHP principle that the criteria weights are independent of these units down below. And that's why they use 1/3, 1/3, 1/3. But when you see what happens here, when you multiply 1/3 times these priority weights, you get eventually a fractional value. I've made them a common denominator, and you must establish a common denominator with them to get these weights. And you'll notice that B is the best. But when you add this one in, D, and if you renormalize your priorities, now the new unit was formerly 11, you add another 9 in there, this becomes 20. When the unit becomes a larger composite, you get the priorities where you've got this reversal. Now A is better than B. So that's what we call the rank reversal. When you add them up, the synthesized for the distributive mode here changes. Now, you'll get that whenever you change the normalization, you use a different unit for measuring your alternatives, and you use the same criteria weights, you're going to get changes in the relative rankings of them as a general rule. Or not in the rankings, but in the relative ratios. And if that is sufficient enough, you're going to get rank reversal. And that's what happened in the case of Belton and Gear. Now, the ideal mode is used in AHP, and we call it the ideal. It was kind of adopted to avoid rank reversal if you wanted to do that. But that mode is similar to the maxima procedure, but not identical, because the ideal mode does not anchor the criteria weights to the units in the columns, as does the maxima mode. Now, it's interesting to note that the distributive mode could have been easily be made or adopted to avoid rank reversal. All you have to do is, when you add a new alternative, don't change your previous composite unit. Simply use the unit the same, and whenever you add or delete things, and use the original set as a benchmark, and you'll never get rank reversal. So an example here, if you use a 3 alternative solution, composite weight, and you added D, you wouldn't have got rank reversal. So what I'm saying here is the unit change is what matters here and is associated with the rank reversal issue. Now, you may be looking here and saying, what method is best? Is it the maximum or the distributive mode? And our procedure, the 3 of us discussing this, really both modes are appropriate, we think. One is not better than the other. It depends upon the nature of the problem that you're trying to solve. Both approaches are different representations for different problems. The distributive mode is appropriate for allocating resources or some fixed quantity sent to divisions or inheritance by an estate. And if you change the number down below, and you're going to distribute that fixed sum in a different manner if you change the number of recipients at the lower levels. So that's something you'd want to do if you have an allocation type problem. The maximum mode is also appropriate when you want to represent, when you want benchmarks, when you don't want your alternatives to change when you add or delete. You want to get some fixation to it. And that's where you use fixed units. What I would say is that different representations can use different units and be legitimate. Some conclusions here, the maximum distributive mode adopt different approaches to measurement. That's the main thing, and they're both appropriate. In the maximum mode, you have fixed units before and after the addition of D, and that resulted in the alternatives being measured in exactly the same way. For the distributive mode, changes are made in the way we measure things. We allow the unit to change. That occurs whenever we renormalize them to new unit sum. A 1 here is not equal to a 1 there when D was added. So D as a recipient in the new unit altered the relative amounts other recipients would receive. And that change in units, along with the same criteria weights, remember, it must be the same criteria weights, in the overall, altered the results in the overall distribution. It just happened in the belt and gear example that the change in relative ratios was sufficient to cause rank reversal. You'll get change in ratio relationships with the distributive mode and maybe not rank reversal. So what I would argue is that you should be looking for ratio stability, not rank stability. And I've frequently wondered about why we argue about ranks when AHP is a ratio technique. Coming back to that statement, changing the way we measure things. Ratio scales are defined by some unit, and the choice of units arbitrary. There's many possibilities for the unit. That variety and abundance in the choice of units is really somewhat undesirable because we want a fixed unit like a pound or a kilo, not something different. In the physical sciences, we have standardized or well-defined international units, but in the social sciences and AHP, they're not well-defined. They're composite units, and they could change, and they have changed very much. But that doesn't excuse us from paying attention to the task of defining what our measurements are measuring. And I would argue that AHP has changed the way we measure things. It's been a wonderful thing to measure qualitative and intangible factors. But I think we have to go beyond that and define what units we're using and describe how they function in different problem representations. And maybe more important, we got to support how the numeric results are credible. We have to do that. So that's basically my message. It is that units matter, and maybe we should look at units when we're using priorities. I hope I'm leaving a few minutes here for some discussion.
There is time because we don't have a third speaker, so.
What you say, Luis?
I said that there is no third speaker, so we only have two speakers in this session.
Oh.
So we have some time.
Good.
Well, I wanted to make a comment. I must conclude that since the reversal happens when you use a distributive mode, and maybe you have to think about the criteria weights change. They're depending on alternatives. The typical example is you change your criteria weights when you observe, for example, you look at houses, right? And what is important to you changes as you get more experience. So that's the way I rationalize that rank reversal. So that's the reason I say when the criteria depends on the alternative is a loop. That's the solution that Pat Harker and I got. And actually, it does come up with the right results. But this effect only happens if you have measures as you had before, that you call it dollars and euros and yens. But the fact is that if we didn't have that, all you had is pair comparisons, right?
Right.
Then it's much harder to say whether actually it should be changing or not, because you don't know what the actual results should be. And so my question then is, you must then prioritize the criteria with respect to each of the alternatives. How much for a given alternative a criterion contributes to the value of that alternative? That's the way I rationalize it. I don't know, do you agree with that, or you think that it's too convoluted?
I agree with that. As you may recall, I was one of the authors of the concept of referenced AHP, which is what you were describing there. I'm also one of the authors on what is called linking pin AHP, where we call those links between the criteria and the units that you're using as the linkages to tie the whole system together. So I do agree with that. But where I may not agree totally is that I do believe there is a role for the linkages not to be there. And there are some types of problems, for example, in inheritance, or you're dividing a budget up amongst various people, or some kind of award system. You have a lump sum, and if the people who are going to get that lump sum, you have another child that's born that's going to inherit something, that may affect the distribution of the people who pre-exist there. And that kind of a problem, you may want to say, I am going to distribute my inheritance, but I'm going to use certain criteria to do it by, and I'm not going to change those criteria. The number of people who are going to receive that money down below may vary, because you may add a recipient or take a recipient away. And so that's the kind of problem. It's the nature of the representation of the problem, I think is correct.
Okay.
But I agree with you, though, that I am in favor, in other cases, of linking the criteria and the alternatives together. And I'd go a little bit further. The linking is the link to the units. I would fix the units that you're making and then use that as a benchmark to consider other alternatives.
Okay.
Long answer, Luis, sorry.
No, that is very valuable. Any other comments and suggestions or questions?
I have one.
Luis, go ahead.
Yeah. Very interesting, Bill. The notion of establishing a unit, I think it's very important. So I've been using AHP and NAP in measuring intangible aspects of value and natural resources for indigenous communities. So it's a kind of expressive rationality. So, for example, the forest has a value that is not measured in monetary terms, but in some kind of intangible aspect. So you compare, for example, the importance of the concept forest with the concept with some other criteria, which may be called territory, the land, just on the general concept. So in those situations, I'm asking if you have any insight of how to establish a common unit in such intangible, for such intangible criteria. What's your thoughts about it?
Well, measuring intangibles is, something we haven't done very well before. But with AHP, it's very valuable. You can do that. But I think what you must recognize is that once you make a pairwise comparison, okay, just a single pairwise comparison, you have a unit. You have a unit in that comparison. And then when you make another one to some other alternative or criterion, you make another one, you have a unit. You don't lose those units. They are there and they go in your pairwise comparison matrix. But when you get a ratio vector coming out, the unit of that ratio, that priority vector that sums to 1, is the total intensity of all of the items that you compared. And so you think of that as your unit. Now, if you want to consider another factor, maybe in your criteria, things you're looking at, you throw another one in, you're changing the unit again. So if you want to, you could look at 3 alternatives or 3 things you compare. You could set them as your unit, and if you want to add another criterion or alternative to your set, you could measure them in terms of the original one you devised if you change your problem. But whenever you renormalize, you're basically getting a new kind of problem here.
My answer to your question, Luis, would be to use a loop.
Use the what?
A loop, like I said, is it like a network, right? You have the criteria and the alternatives. It's a loop.
Yes.
And that in a sense, it adjusts the unit appropriately. It's one way to implement that changing in the unit. If you didn't have a unit, you didn't know what the unit was. Because you are using pair comparison, it's all relative priorities. So that's what I would do. I don't know if it makes sense or not to do that. Is giving an alternative, how important are the criteria for that alternative? And so that's, some people say this doesn't make any sense, but I think that makes sense to me. So
I like the concept of a composite unit at the very end. And that I don't know if I'm right or not, but that captures the meaning. When we're talking on expressive rationality, that would capture, that sort of composite unit capture the total meaning of whatever people is perceiving about its surroundings, its, their environment. Yeah. So it's very interesting. We don't know what kind of unit is, but we know it's a composite of all of the way of perceiving, thinking, and appreciating something in the intangible way. So the loop is, I agree, it's one way to close it. Mm-hmm.
If you look at international standards, if you're going to communicate what you're talking about, it's useful to say, what is your unit? We're talking about ratio scales with AHP. And ratio scales have a unit, and usually we ignore that. So I think it may be useful if we can use that to communicate correctly. And I think this kind of a thing occurs in other areas. We also looked at several issues of Simpson's paradox, which is a standard thing in the literature and statistics and so on. And a lot of the Simpson's paradox is just getting a different unit and measuring it differently. Well, the same kind of thing I think happens in AHP.
Could I say something? I'm a little bit embarrassed to go up against you 3 guys who are amazing mathematicians and know what you're talking about. But I had a little something to add here. Before I do that, though, let me say that Bill Wedley, Luis Vargas, John Soddy, and I were at the very first International Symposium on the AHP in
Oh, yeah.
1988.
Mhm.
So welcome, guys. I'm so glad you're here.
Well,
Okay.
we
About
also
yes, Bill?
We also wish other people were here too.
Oh, yeah. Oh, yeah.
We're just a
Miss
little
it
lucky.
every day still.
Yeah.
So what I kept asking Tom for many years, what do you call the scale, the priority scale that you get when you do pairwise comparisons and you get a priority scale from it? He says it's an absolute relative scale. This word relative is really important. I didn't appreciate it for a long time, but what it means is you're giving up your units. Once you convert to a relative scale, all you've got is the relativity of it. And an AHP environment is a whole relative thing. The criteria are relative, the alternatives are relative. You're giving up, okay, did I start with $2 or $20? You know, you don't know anymore and you don't even care, because the relativity, the advantage of having a relative situation is that you've washed away the need to make different units commensurate. You don't need it anymore, because all you're interested in is what's there now, what's the best that's going to come out of what's there now. So when you're distributing a resource down from a goal to the criteria all the way to the alternatives, think of it as pipes. You know, maybe the pipes don't change up here, but as you add the alternatives, they're little pipes that are getting priority from above are changing in all kinds of unexpected ways. It's relative to what's there right now. And in the other situation, when you're adding the alternatives at the bottom, they're bringing the resource in with them. They're changing the amount of the resource. They're changing the priority of the criteria, because the amount of it that's there with the new alternative is different than it used to be. So you have to kind of rejigger it into a new relative situation. Anyway, that's just my contribution. Tom called them absolute relative scales.